Greetings from KSR College of Arts and Science for Women. I am Dr. David Kirubakaran, Assistant Professor, Department of Physics. Now we are going to see the glimpse of condensed matter physics in a short time period. Let's move into the topic. Condensed matter system is a very large number of constituents. We study how matter arises from large number of interacting atoms and molecules and electrons, and what physical property it has as a result of these interactions. The other characteristic is the strong interaction between these constituents like atoms and molecules and electrons, compared it with respective to the kinetic energy. The field of condensed matter physics explores the macroscopic and microscopic properties of matter. Condensed matter system can be classified into two types. One is solid, another one is liquid. And the other systems like gas, plasma molecules can be excluded except very few large molecules like DNA. The CMP considering a physical property of a system from its atomic structure. What is the importance of CMP is because it can help us to understand the world, how our biological system is working, why some metals are cold, why water is wet, and all these. It has a large number of atoms and molecules and strong interaction between one among them. CMP helps in daily our life. On many devices, if we don't understand the concept, we may fail and face the consequences in fabricating ICs. When it's work, it will burn. Here is the main point. CMP is the bridge between the quantum physics and macroscopic materials. Macroscopic physical properties: phonon spectrum, heat capacity, hardness, superconductivity, etc. Microscopic physical property: crystal structure, growth and phase transition mechanism, etc. Now we have to know how condensed physics is organized, how we have two systems. One is hard matter, another one is soft matter. The difference between these two types is interacting between the constituents. The interactions are weaker. This can be called as a van der Waals interaction. The interaction are strong. This can be called as the ionic structure or covalent bond. Now we have to know about bonding. The individual atoms must be held together in solids by interatomic forces or bonds. These forces of attraction thus bind between the atoms very strong according to the strength, order and stability. Chemical bonds are grounded into primary and secondary bonds. Now we have to know about primary bonding. The primary bond, by virtue of their nature and interatomic bonds, it has three types. One is ionic bond, second one is covalent bond, another one is metallic bond. The second type is secondary bond. The secondary bonds are intermolecular bonds. Now we are going to see the example. One is van der Waals, another one is hydrogen bond. Now we are going to see the lattice vibration. We have to know what is lattice. We all know that what is lattice. It means regular arrangement of atoms. In other words, n-dimensional array of points, each of which has the identical surrounding. The lattice vibration is the oscillation of atoms in a solid about the equilibrium positions. For a crystal, the equilibrium positions for a regular lattice due to the fact that atoms are bound to neighboring atoms. The lattice vibration can be explained: sound velocity, thermal property, elastical property of the material. Lattice vibration is the oscillation of atoms in a solid about the equilibrium position. Now we are going to see the lattice vibration in one-dimensional monoatomic molecules. A one-dimensional crystal lattice, and assume that the forces between the atoms in the lattice are proportional to relative displacement from the equilibrium positions. Now we are going to see the next topic, that is phonon. The energy of the lattice vibrations or elastic wave is also quantized, and the quantum of energy is known as phonon. The phonon have the wave-particle duality, and both are characterized as the quasi-particles. The number of phonons may change with the temperature of the body. Now we are going to see the examples. Thermal vibrations or thermally excited phonons. The second one is sound waves or acoustic phonons. The third one is excitations of optical branch in crystal generation of optical phonon. Now we are going to see the types of phonon. The first one is optical phonon, second one is acoustical phonon. The first one we are going to see, that is optical phonon. The optical phonons are quantized mode of lattice vibration when two or more charged particles in a primitive cell move in opposite direction with the center of mass at rest. The second one is acoustic phonon. Acoustic phonons are coherent movements of atoms of the lattice out of their equilibrium position. These are the highlights of bondings and lattice vibration in condensed matter physics. Thank you for watching that video. Thank you all.